Hey guys, all right, since I'm not here, this is your lecture for today. The position of a body at time t is s equals t to the third minus 6t squared plus 9t meters. Okay, so this m right here means the unit of measurement. In this case is meters. Find the body's acceleration each time the velocity is 0. Okay. So let's talk about acceleration. It says find the body's acceleration. So acceleration with respect to time is the same as the first derivative of the velocity, which is the same as the second derivative of the position formula. So we have the position right here. So what we might want to do is find s prime of t to give us the velocity. So that's 3t squared minus 6 times 2t, okay? Because 6 is the constant, you can pull it out, make it weight, and just take the derivative of t squared, and the derivative of 9t is just 9. So now s prime of t is 3t squared minus 12t plus 9. But I want, what is it that I want? Okay, I eventually have to do second derivative, but let's talk about this question. Find the body's acceleration each time the velocity is 0. Well, this is already the velocity, right? Because it's the first derivative of the position. So I have to take that and set it equal to 0. So 3t squared minus 12t plus 9 equals 0. Let's try to factor out a 3 to make it smaller so we don't have to work with such ginormous numbers. So t squared minus 4t plus 3 equals 0. So divide both sides by 3. 0 divided by 3 is 0. So technically, we only have this left to factor. So we have t minus 3 and t minus 1 equals 0. So t equals to 3. So at 3 seconds and at 1 second later, okay? So the velocity is 0 at those time frame. Okay, so velocity is well, that doesn't look like an S. Okay, I was gonna merge the S and the 0 together, and as you can see, it didn't work out so well. Okay, is 0 at 1 and 3 seconds. Okay. All right, but I'm really not interested in that right now. I'm interested in the acceleration when it is at 0. So I need to take the second derivative. So here we go. Second derivative of position is, I'm going to use this equation right here. Okay, so that's 3t squared. The derivative of 3t squared is going to be 6t. And then the derivative of negative 12t is just simply negative 12. So now, this is acceleration, okay, with respect to time. Well, it says find the body's acceleration each time the velocity is 0. Well, the velocity is 0 at 2 locations, so I have to find both. So t, a of t, in this one, let's use 1 first, okay? So a of 1 is so this is the second, okay? So the first time the velocity of 0 is 1, so I'm going to plug 1 in. So 6 times 1 minus 12 equals 6 minus 12, which is going to be negative 6. And then because this is acceleration, we might have to write the correct unit of measurement, so make sure we have it as second squared, okay? Then you can do the second time, which is at 3 seconds, so plug it in. So you can do 6 of 3 minus 12 equals 18 minus 12, so that's positive 6 meters for second square, okay? So what does it mean by negative acceleration? Okay, so two things with negative acceleration, because you can see there's a positive and negative answer. So negative acceleration. Oh, it's okay. You don't have to. You can pull it all the way up. Yeah. Sorry, just talking to one of my students. Negative acceleration can mean two things, right? So it can slow down, or it's slowing down, and it's speeding in the opposite direction, okay? speeding in the opposite direction. Okay, so how would I write the final answer? Here we go. The object is accelerating at, the object is accelerating at t equals 3 seconds I'm sorry, I should use the don't erase. Sorry, at 3 seconds, it's at what, 6 meters per second? The object is accelerating at 6 meters per second square at 3 seconds. There's a lot of at, isn't it? That sounds confusing. The object is accelerating at 6 meters per second square at 3 seconds. Okay, and negative 6 meters per second squared at t equals 1. There's just a lot of at in there, so that sounds really confusing. Okay, so I'm going to read that one more time to see if it makes sense. The object is accelerating at 6 meters per second squared at 3 seconds, and negative 6 meters per second squared at t equals 1. Okay, so that sounds okay. All right, next one. Example 3. A particle P moves on the number line shown in part A of the accompanying figure. Part B shows the position of P as a function of time t. So let's look at the two parts, okay? And since I didn't label A and B, let's do A and B. Here's supposed to be your part A, and here is your part B. Okay, so this is part A. It's the particle moves on the number line. So that's why we have a number line. Okay, so moving back and forth, back and forth. And part B shows the position of P as the function of time t. So B is shown how high it is as time goes on. Okay, so letter A. When is P moving to the left, and when is P moving to the right, and when is it standing still? So let's talk about left, right, and standing still, okay? Under your summary, we have written down left and right and standing still, okay? So left is when v of t, the velocity, is less than 0. Moving right, it's when the velocity is greater than 0. Standing still or about to change direction, okay, standing or stopping is when v of t is at 0. So let's look at our position, because if I take the derivative of it, then I would have all of the answers. So the derivative of position, so this is s of t because it says position, okay? So let's look at the derivative. So it looks like issues are, we have some funky looking thing right there, and right there, and right there, and right there, and right there. Would you agree? So all of those spots are pretty much weird things that we have to look out for. So what's going on? What's happening with the slope or the derivative at all of those red marks? So I want you to think for a second, okay? What's the derivative of all of those red circles? Would you agree that the derivative is not defined? Okay. So let's start with left, okay? Left. Left is I'm looking for the derivative being negative. So I'm looking for the slope of the position being negative. So the slope of the slope is negative. So first slope I see that's negative is right here. Okay, so that's this negative slope right there. So that time, this is 0, this is 1, this is 2, this is 3, that's 4, this is 5, this is 6, this is 7, this is 8. Okay, so would you agree that is negative from 6 to 7? Okay, so left from 6 to 7. Because this is undefined, so I can't use it. So I can't just say, oh, you know what? It's turning left continuously from 6 all the way infinitely. Well, that's really not true. Well, let's keep this. How about make it 9 and make it 10? Add on 2 more tick marks, okay? And make it n. So we are going to go, hey, you know what? Let's make that from, there's some undefined values at 7. So 7 all the way to 10. So that's your left. Okay. Then let's do right. Right means I should have a slope that's positive. So positive slope is right here and right there, okay? So we will have right is from 0 all the way to, let's make this what, 1.5? Okay, so that's right 1.5, union that with, this is 3 to, what do you want to make this, like 4.5? Okay, so let's make that 4.5. Just stay on the same track here. So that's when the object is moving to the right. Now, when is it standing still? So standing still, let me use a different color. Okay, so standing still. Okay, keep in mind standing still is when the velocity is 0. That means the slope is 0. So the slope is 0. It's right there. Can you see that? And right there. Okay, so standing still, I have it at 2 places. It's going to be from 1.5 all the way to 3, union that with from 4.5 all the way to 6. Okay, so that's all of the spots that it's going to have a slope of negative slope, positive slope, or when it is 0. Okay. All right. Part B. Graph the particle's velocity and speed were defined. So I'm going to do 2, velocity and speed. Okay, so let's do velocity over here. So this is time, and this is v of t. So I'm really pretty much graphing s prime. And this is speed. Can you tell me the difference between velocity and speed? Do you recall what the difference is between the two? I'm going to change this to make it lower. Can you tell me the difference is between the two? What's the difference between velocity and speed? The speed is an absolute value of velocity, so it's only positive. That's why I'm making this slightly bigger on the y-axis, where it's more positive. All right, so I have 0 to 10 seconds, so let me do those marks, okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Then I'm going to give you a second to give it a chance. I want you to try it out, and then I'll come back and kind of fill in the gap if needed. Okay. So I'll put like a minute on the clock. Were you able to figure anything out? I'm gonna go in and put some tick marks in here. Okay, so if you did it or if you were trying and wasn't very successful, let's work it out together. Okay, so this is right here, as you can see, 1, 2, 3, 4. Okay, so this point is 1.5 comma 3, and this right here is 0, 0. So what I'm gonna do is I'm gonna try to find the slope for that, okay? From 0 to 1.5. So the slope for that is just really what? The delta y divided by the delta x. So it's gonna be 3, which is y minus 0, all over 1.5 minus 0. So that's really 3 divided by 3 halves, right? Which is really 3 times 2 over 3. So the slope of that is 2. So what are you going to do with that slope? I'm going to go in and plug it in. From 0 to 1.5, I have a slope at 2. So the slope is defined at, assuming that this is a closed dot. So we're going to assume right now it's a closed dot because it didn't say. And then it's defined from 0 to 1.5. So that's my slope. Then the slope from 1.5 to, looks like 3 is 0. So that's open circle, 1.5 to 3. So that slope right here is 0. Okay. Then this slope, I would have to figure out what that is. Okay, so let's figure out. This is 4.5 comma what? 1, 2, 3, 4, 5. So 4.5 comma 5. And this point right here is 3 comma 3. So let's find the slope for that, okay? I need space for scratch work. So if you have space for scratch work, write it somewhere so that's not going to be confusing for you to look back later. So I'm going to use delta y, so 5 minus 3 divided by 4.5 minus 1.5. So that's really 2 over 4.5 minus 1.5, that's 3, so 2/3, okay? So positive, almost 1. So that's from what? 3 to 4.5, so 1, 2, 3, so almost 1, open circle. 1, 2, 3, 4, 4.5 is right here, open circle. So that's the velocity. So right now, most of this is 0 or positive, which we understood because it was going to the right, right? Okay, and then let's look. This is also 0 right there. Can you see that? So from 4.5 to 5 is that 4.5 to 5 or is that 4.5 to? Yeah, 4.5 to 6, my bad. 0, 1, 2, 3, 4, 5, 6. 0, 1, 2, 3, 4. Oh, did I? Oh, let me see my x value here. Did I like sketch this one wrong? Okay, 4 from 3 to 4.5. 1, 2, 3, 4. That's 4.5. Let me number these. I'm like confusing myself. 1, 2, 3, 4, 5. Okay, so 4.5 is okay. From 4.5 to 6. 1, 2, 3, 4, 5, 6. Yep, 6. Okay. The slope is 0. Okay. I don't have it numbered, so I'm like totally confused by it. Okay. So now let's look at this next piece right here. Okay, let's figure out the slope. Actually, that one's a nice one. I can count. Down 2, right 1. So the slope is just going to be -2. So down to right 1, so the slope is -2. So from 6 to 7, the slope is -2. Okay. All right, last piece. Here we go, from 7 to 10. So let's use this one, 7 to 10. What is the slope, okay? So this is 7 comma 1, 2, 3, 7 comma 3. And this is 10 comma 1. So what is that slope? 1 minus 3 divided by 10 minus 7. That's -2 over 3. So -2/3. So this is 7, this is 8, this is 9, this is 10. Okay, so it is from 7 to 10, it's negative and is close to -1. So here, to all the way here. I just have to be careful because okay, the slope is negative 2/3. Okay, so there you go. So that's the graph of the velocity. And I just have to be really careful. There's a lot of basic math, and I tend to get my basic numbers incorrect from time to time. Okay, so now let's do the speed. The speed is nice because all I need to look at is the velocity work, and I've already done all the hard work. All the basic math is done, and remember, that's the part that I always get wrong. So, but I do need to number these because that was the part that was kind of confusing for me. Okay, and then I'm gonna go up to 1, 2, 3, 4. If it's not labeled, then I'm assuming it's by ones. Okay. Okay. Well, look at this. The first bar is already positive, so I don't even have to do any work. Oh, you know what? Put closed circle here because the last one, because we are gonna assume that's closed circle on the position, so it's gonna be defined right there. So the left-hand derivative is gonna be okay. All right, so the first one is gonna be exactly the same as the velocity because it's already defined. The second one, it's okay to have speed of 0, so that's okay to have right there. The third one looks like, I remember it was 2/3, right? So I'm going to go up to here. 4.5 is here. And the next one, the fourth one, again, is back at 0. So the only difference is right now we only have 0 and positive. So that's why all of this is still here. Now the next one, I remember the slope was a -2, but I can't have -2. So I have to bring it back up to here. And that was 6 to 7. Okay, so if it's a negative slope, so you have to bring it back to the positive side because it's an absolute value. Okay, and then same thing, that was a -2/3 from 7 to 10, and this is closed circle. Okay, then we're gonna go that way. So bring that back to the top. See right there? That's the only difference between velocity and speed. Okay, now if I'm going too fast, please do tell somebody to hit pause, okay? Example 4. The accompanying figure shows the velocity. Oh, so this is S prime. Oh my goodness. Okay. V of t. Shows the velocity V equal to F of t of a particle moving on a coordinate line. When does the particle move forward? When does the particle move forward? So keep in mind that moving forward or moving right is when the velocity is positive. When does it move backward? Move backwards is when the velocity is negative. Okay? So this is already velocity. So would you agree the velocity starts at 0, assuming these are like closed dots, okay? And it's positive from all the way there. Whoa, and this is like 30, okay? So moving forward, okay, it start at 0, so I guess at 0 technically we're not going anywhere yet, right? We're just starting. So 0 all the way to 30, okay? Then it's going backwards, okay? Backward is starting at 30. So 30 is where it's 0, and that's where it's about to change direction. So it's not going anywhere, it's holding still, okay? All the way to, this is negative right here. Woo, right there, and that's 50, so that's 55, okay? So 30 to 55. When is the particle's acceleration positive? And when is it negative? And when is it 0? Okay, so let's talk about, if you remember, how do I know if the acceleration is positive? So, positive acceleration, meaning that the V prime is, because keep in mind A of t equals V prime, so it has to be what? Positive or negative? Positive, right? Okay. And then when do you think it needs to be, when is a negative acceleration? When a of t is less than 0. And when it's 0, then when it is 0, okay? When the derivative is 0. So let's look at the positive. So this is v of t. So if I take the derivative of v of t, that will give me acceleration, a of t. So from here to here, it looks like that is a positive, right? These are the undefined spots. Would you agree? Okay. So I have a positive slope from 0. So positive from 0 all the way to 10. Is that the only one that's positive? How about here? Could we say that this is positive? Down here in the bottom? Yeah, for sure. That is also positive, right? That's positive from 40 to 55, okay? So it's positive acceleration from 0 to 10 and 40 to 55. Negative acceleration is when the derivative, the slope is negative. So let's look at a couple of negative. Would you agree? It's negative from here all over here straight through. Okay, so how should we write that? So negative, okay, from, looks like this is what is that right there? 15? 15 all the way to 40, right? So that's negative slope. Then 0 acceleration. When is the 0 acceleration? When the slope is 0, right? So here, from here to here. So that's what, 10 to 15? So that's 10 to 15, okay? So positive acceleration is really, you are looking at the positive slope for velocity. The negative acceleration is you're looking at negative slope for the velocity or from the velocity graph. Then 0 means you're looking where the slope is 0 from the velocity graph. When does the particle move at its greatest speed? When does the particle move at its greatest speed? Well, think about this. Speed is the same as velocity, except it always has to be positive. So if you look at the negative velocity here, the largest number is negative 40. If you look at the number up here, the largest number is 60. So the greatest speed is, so you just have to look at the highest number on the y, right? So the highest number is 60 miles per minute, right? 60 miles or meters. It doesn't say m, so I'm assuming that's miles, meters per minute, okay? And if you really want to get fancy, we can even put the time, okay? When does a particle move at its greatest speed? The greatest speed is 60 meters per minute at, when means we're looking for time. So that's from 10 to 15, from 10 to 15 seconds, how about that? From 10 to 15 seconds, okay? From 10 to 15 seconds. Or minute, I'm sorry, this unit is minute. That's a long time, okay? So when means I'm really looking for time, okay? When does a particle move at its greatest speed? The greatest speed is 60 meters per minute from 10 to 15 minutes. When is the particle speeding up and when is it slowing down? Okay, so let's talk about speeding up and slowing down. We have not mentioned this. So speeding up, okay? I'm spelling everything out. Speeding up means both a of t and v of t have the same sign. What does that mean? That means they're both positive or they're both negative, okay? So both positive or both negative. Slowing down, okay, means A of t and V of t have opposite signs, okay? All right, so one's positive, one's negative, vice versa. So let's talk about when is it slowing. Let's do, oh, I wrote speeding up first. I guess let's do speeding up first, okay? Speeding up. Okay. So would you agree from here to here, velocity is positive because it's above the y-axis. And the slope is also positive because it's going in the positive direction. So that first piece right there would constitute speeding up, okay? So from 0 to 10. And then what's happening right here is that this is the slope of 0. And earlier we said the slope of 0 is not, right? We are doing what at the slope of 0? We're not doing anything, right? The slope of 0, we're changing direction. V of t is 0, is changing direction. Well, another spot, okay, so look at this piece. Even though this is above the velocity, oh, different color. Okay, so this piece right here, see that right there? That piece has negative slope, but the velocity is positive because it's above the y-axis. So that's opposite sign. So that is really my slowing down. Okay, slowing down. Okay, so that is from 15 to 30. Then let's look at the next piece. Okay, how about this one? This piece right here is velocity is negative because it's below the y-axis, and acceleration is negative because the slope is negative. So that piece right there is actually speeding up because the signs are the same, okay? So that's actually speeding up, and that is from 30 to 40. Okay, then let's look at the following piece, like this piece. That piece, the velocity is negative because that is below the y-axis, but the acceleration is positive because the slope is positive. So because that is opposite sign, I'm going to say that is slowing down. So that's from 40 to 55, okay? So that's how we constitute speeding up or slowing down. All right, I think this is enough notes for one day. Have a wonderful weekend, and I will see you when I get back.